So now we talk about dimension shifting. So say you start with something like this. You have a short exact sequence. This f is flat right here. So this will give you a long exact sequence. The long exact sequence you will get is, you will get torr of n plus 1. You start with this, a comma d, something is coming in, then you will have torr of n plus 1, f comma d. This will go to torr of n plus 1, b comma d, and you come back again, torr of n, a comma d. You have torr of n, f comma d, torr of n, b comma d. Yeah, so this is how the sequence keeps going on, yeah, till you reach 0. Anyway, we'll just take small part of the sequence here. We'll just starting from here, we are taking this portion out. So this is what we have written down here. So in this portion you see that since this is a flat module, this is 0 and this is 0. So there is an isomorphism right here, and that is what is dimension shifting. There's a isomorphism between n plus 1 and n. This is 0 and this is 0. So now you consider another short exact sequence. Now E is injective. You apply the X group to it, you get a similar sequence: x10 d comma e, x10 d comma d, x10 plus 1 d comma a, d comma a. So this is here, notice that this n is increasing. So again, since E is injective, this will be 0 and this will be 0. So you have isomorphism right here. So let us try to write this sequence down. You have the sequence like this. You have the sequence like this, x of, now we are using a covariant functor here. So you have x of d comma a, it's going to x of d comma e, x of d comma b. So this is, say, n. Since this is x group, it will increase in number, x of n plus 1 d comma a, x of n plus 1 d comma e. You have x of n plus 1 d comma b, and so on. And we are just considering this part of the sequence. We are saying this is 0 and this is 0, and therefore there is isomorphism right here. And this is the example again of dimension shifting.